All right, we're back. So next section, we're going to talk about more of what's going on in the nucleus. And first thing, what happens when we have two opposite charges, like a proton and a neutron? They should attract. And if we have two of the same charges, like two protons or two electrons, kind of like two magnets, if we have the north pole of two magnets, they should repel. All right, so opposite charges attract, like charges repel. So let's think then just about the nucleus. And as we're dealing with nuclear chemistry, a lot of times we're not even going to mess with talking about the electrons. We're interested in what's going on in the nucleus. So here's a helium atom, or we're just going to look at the nucleus, 4/2 He. So that means the mass is 4. So the total number of protons and neutrons together are 4. 2 of those are protons. So this would kind of be my nucleus. I've just put 2 protons and 2 neutrons there. It would have 2 electrons, but we don't usually represent that at all in this. We don't talk about the electrons. So the question is, if like charges repel, why doesn't the nucleus fly apart? I've got 2 positive charges. They should try to repel each other. Since it doesn't, and we can even think, carbon with 6 protons, calcium with 20 protons. Something else is going on, and that nucleus is being held together. There's some other force that's overcoming that repulsive force from the protons. And that is called the strong nuclear force. So this force is what's responsible for holding our nucleus together. I've kind of seen it modeled before, almost like bungee cords that kind of help to attach and hold atoms together. We know a bungee cord won't stretch forever, so it can only work over a short distance. But that's kind of what our strong nuclear force does. It's an attractive force between particles in the nucleus, but it only works at really short distances. So we're going to start talking about something called the neutron to proton ratio. So if we think about these like proportions, we would write neutrons on kind of like top. So if I had, we looked at carbon before with 6 protons and 6 neutrons. So I'm going to do neutrons on top, protons on bottom. So carbon 12 would have 6 neutrons, 6 protons. So it would be a 1-to-1 ratio of neutrons to protons. From our last one, we also talked about carbon 14. Carbon 14, again, it's still carbon, so it has 6 protons, but it has 8 neutrons. So that's 8 to 6. So if we would reduce that, that's going to be a ratio of greater than, well, what would that be? This would be 1, 4 to 3, 1.33 to 1. I hope that math's right. I should have done it before I recorded. But that would be a greater neutron to proton ratio. We're going to look at these in terms of a graph. And your assignment that you're going to do, you're actually going to make a graph that looks just like this. We're going to put proton number on the bottom. So we're going to be like 1, 2, up to whatever number of protons. And then neutrons, again, the same way, 1 up to how many ever neutrons. So for our carbon 12, we had 6 protons, 6 neutrons. What you're going to do, you're going to find some of these things, and you're going to find where your number of protons and your number of neutrons are. So like say carbon 12, we would have 6 and 6. We would find where those meet, and we would put a dot for that. If we were to graph carbon 14, I would have a higher number of neutrons, but still have 6 protons. So maybe I would have a dot in a different position. So what you're going to do is graph. In a graph like this, and I've included graph paper for you, you're going to graph a bunch of stable atoms. Atoms that have a good proton to neutron ratio. And you're going to draw a line for those. And then you're going to graph some unstable atoms and see how they compare to this particular stable ratio. Not every single nucleus is stable, what means it doesn't want to stay together, which is where we get into the whole nuclear reactions. The strong nuclear force, for some reason or another, can't keep the nucleus together, so the nucleus falls apart, and that's kind of where we're going. So what I'm going to have you work on is the assignment called the band of stability, and you're going to make a graph similar to the one I kind of previewed for you. You're going to graph in your stable atoms, put a line, graph in your unstable atoms, and there will be just a few questions.